All right, so here we're looking at 10.1 homework assignment. What I did here is I just kind of copied the homework assignment problems, and we'll try to go through them. So this first one, determine whether correspondence is a function. This answer, as you can see, I put yes, but let's talk about why. So a function is defined as each x value has only one y value. So this is a great example. Remember, your domain stands for x values, right? Domain is x values. Range is y values. So here we have x, here we have y, we have 19, 24, 6, we have 16, 10. You see that this 19 has one y value. This 24 has one y value. And this 6 has one y value. So this is why, yes, it's a function. An example where it would not be a function could maybe be something, let's say 19, 24, and 6. We still have these again. How about if this 19 went to 16 and also went to 10, and then 24 went here, and we can even say 6 went there. This would be no, because we see that 19, or let's say when x is 19, it has two y values. One thing I think is really important just to understand is that if x is repeated, it's not a function. Right, if x is repeated, it's not a function. Once again, another way of looking at it, I mean, our first ordered pair, we have 19 that goes with 16. Right? We have 19 that goes with 16. We have 24 that goes with 10. And then we have 6 that goes with 16. Here you can clearly see x is not repeated any of the times. Once again, that's why our solution, yes, it's a function. Okay, so the same thing here. Is this a function? Well, as I mentioned before, you need to ask yourself, is x repeated? There's this. All right. Is x repeated? We see no, it's not. Therefore, it's a function. Right? Okay, next example here. I want to give the domain and range, right? So the domain stands for all the x values, And we always, when we show domains and ranges, let's say when we show domain in range, what's happening here? Let's see. I don't quite know what's happening. So we show domain and range for graphs. We show in interval notation. All right, and let's not forget interval notation. Right, it's either gonna start with a open bracket or open parentheses, followed by the smallest number, followed by a comma, then the largest number, then close bracket or close parentheses. Also important to note that close bracket, or these brackets, mean that it includes the number. Our parentheses, and we can show them either way, right? Parentheses means it excludes the number. Okay, so some important things to understand here. As we take a look at our x values, the smallest x value we can see here is -8. We see this closed circle, therefore it includes -8. So that's smallest x. This right here would be largest x. This closed circle means includes. Open circle over here means excludes. So this domain, it includes -8 when it includes, open bracket, includes -8, comma, it excludes 7. Does not include 7, so we put parentheses. So this is our domain. Now let's take a look at our range. Smallest y value is right here. Let's do that. And it hits -9, so it includes. Largest y value is right there. It hits 9, so it includes. All right, so our range, smallest y, -9, largest y, 9, and they include them, so that's why we put brackets. So a nice example to number 3. Number 4, same idea. Let's take a look. This one's interesting because this keeps going, right? Because it keeps going, it tells us smallest x is -infinity. It will never reach -infinity, so it excludes it. Also, the fact that on this end it keeps going, right, tells us largest x is a positive infinity. It can never include the infinity, so once again it excludes it. So this domain, -infinity, positive infinity, cannot include them because it will never reach it, so we put parentheses. Y value, well, once again, the fact that this keeps going down tells us that we have the smallest y value, -infinity, once again, excludes. But as we start going up, this is the highest that it reaches. It does not go higher. Right, so this right here is the largest y value, and here we can see that it includes it, right, because it actually hits that number there. So our range, open parentheses, negative infinity, comma, and then it hits the 6 with our bracket. All right, so some nice examples of domain range. Okay, now we are looking at this function, and we want to find what this is first, that next, and that last. So let's take a look at this example. Once again, let's f of x equals 4x squared minus 6x plus 6. We want to find f of x plus h. Right, so all we're doing here is we are going to put this in for each x. Okay, that's all we're going to do. All right, so doing that gives us a 4, open parentheses, x plus h, close parentheses to the power of 2, minus 6, open parentheses, x plus h, close parentheses. Then we have plus 6. So this tells us that we have 2 of these x plus h's. Bring everything else down for now. Now we can start distributing. I'll distribute there and there. And I'm going to put that in its own parentheses. This negative 6, I'll distribute there and there. Okay, now from here, I distribute, I FOIL, right? Same thing here and there. I'm just going to arrange my letters here so they're the same, but it doesn't matter. Bring everything else down. I'm going to combine like terms. Looks like these two can definitely be combined there. All right, so you get plus 8xh plus 4h squared. Looks like we write everything else. And I think that's as far as we can go. 4xh plus 8xh plus 4h squared minus 6x minus 6h plus 6. All right, that is our answer for part A. Part B now tells us to find f of x plus h minus f of x. We should be able to do this very easily. Keep in mind that the answer that we just did previously, right, is just x plus h, which means we can replace this x plus h with that whole thing. So I'm going to need some room. So I got 4x squared plus 8xh plus 4h squared minus 6x minus 6h plus 6 minus, open parentheses, right, your f of x is just the original problem. Right, so now we're going to put that in. Minus 4x squared minus 6x plus 6. Okay. We distribute. I bring this down. And now I distribute. I get minus 4x squared. Negative and negative make a positive 6x. Negative and this positive make a minus 6. And I combine like terms. What do I see? I actually see some interesting things here now, right? 4x squared minus 4x squared cancel. Minus 6x plus 6x cancel. Plus 6 minus 6 cancel there, all right? So we see some cancellation occurring here. We're left with 8xh plus 4h squared minus 6h. And I think that is my solution. Let me just double check here. Plus 4h squared minus 6h. What am I missing here? 8h plus 4h squared. Plus 4. Oh, I don't think I just think I typed it in incorrectly. Let's take a look. All right, wonderful. So yeah, that answer is correct. Okay, last part C. We want to find f of x plus h minus f of x. Put this whole thing over h. All right, so keep in mind that B, what we just did, is actually that top part. All right, let me fix this. The answer that we just did is that, right? Our answer is this entire thing. And if you notice, this entire part on B is on the top of what they want us to do. So from there, all we really have to do is we just say, we rewrite our answer that we just got, and we put it over H. Here we see that this top portion, all of these have an H. So we're going to rewrite that problem. I'm put an H on the outside of a parentheses, and I'm just going to write 8x plus 4h minus 6. As you can see, what I did is I took an h away from here, an h away from there, an h away from there, and I just put it on the outside. This is called factoring. And I just divide this by h, all right? I just rewrite the bottom. And I see these h's cancel, and our answer here is 8x plus 4h minus 6. So a very nice example. This is definitely looked at quite a bit in a calculus class as well. So a good example to look at. Okay, next example here, the same idea, right? First we're finding, first we want to find that, then we find f of x plus h minus f of x, then we divide it by h, just like we did earlier. Okay, so part A, once again, this entire thing is going to go into your x, all right, like we did before. So this is just 3 over x plus h. It doesn't look like we can do anything else there, so that's it for part A. Part B, we want f of x plus h minus f of x. And just like before, we already did this part. This part was that answer. All right, so all we have to do is rewrite it. So it's 3 over x plus h minus f of x is our original problem. So it's minus 3 over x. Here we're subtracting unlike fractions, so we have to find our LCD. Our LCD is just going to be the first denominator times the second denominator. So let me just start off by rewriting our two fractions. What we're going to do is we're going to multiply the first fraction by x, the second fraction by x plus h. And because now we're left with 3x on the top, on the bottom, x times x plus h, minus on the top 3, open parentheses, x plus h, close parentheses, on the bottom, x times x plus h. And since our denominators are the same, we're just going to show one fraction now. We're going to put everything together. Rewrite our denominator just one time. From there, we can distribute 3x minus 3x minus 3h over x times x plus h. We see that we can cancel 3x minus 3x. So we're left with the negative 3h over x times x plus h. Can't be simplified any further. So that is our answer to that first part, that second part there. And I am just going to double check here, making sure that we're on the right track before we continue. So let me put these answers in. All right, very good. Now we can do C, which is to find f of x plus h minus f of x over h. And just like before, this top part, we already know. This top part is this as our answer. All right, so I'm just going to rewrite that. This is negative 3h over x, open parentheses, x plus h. This entire thing is over h. This does look ugly, but I'm just going to rewrite it as we're dividing fractions. So this is just negative 3h over x, open parentheses, x plus h, close parentheses, divided by h over 1, right? Or in other words, 3h over x, open parentheses, x plus h, close parentheses, times 1 over h. I see a h on the top, h on the bottom, cancel out. And negative 3 times 1, well, that's just negative 3 over x, open parentheses, x plus h, close parentheses. And that is our answer for part C. So we've now completely answered this problem. Okay, and these last two problems, really nice examples here. All we're doing is looking at a graph and identifying if it's a function. We can do this by the use of our vertical line test. All right, so all we have to do is draw some vertical lines. Here I see I do one vertical line. Since it hits this graph twice, all right. Vertical line hits graph twice, so it's not a function. All right. How about this next example? This vertical line hits it once. Any vertical line that I do only hits it once. So this is it a function? Yes. Why? Because each vertical line hits the graph only once. All right, you have any more questions on this homework assignment, just email me or schedule a meeting with me.